All right, so in this video, we're going to continue looking at solving trig equations, but we're going to be looking at ones where an identity needs to be used. Now, I did one in the previous video because it kind of fit with things that are quadratic in form, but to go from the first to the second step, I needed to use a Pythagorean identity. You know, that identity that says sine squared x plus cosine squared x equals 1. So sine squared x would have to equal 1 minus cosine squared x. So I was able to replace sine squared x with 1 minus cosine squared x. Okay. The reason I thought to do that is I needed all cosines in there, I felt like. And if I could get the cosines in there, I knew it would be a cosine squared x, then I would be able to get it rearranged to be quadratic and go from there. Okay. All right. Now, really, I wrote this one in, but I think I need to do, where is it? This one first. So let me look at example 10 first, because there's a little thing that happens on this problem that I want to look at. In fact, I'll just put that earlier. So before I do more where you need to use a trig identity, let me take this one. Sine x tan x equals sine x. Sine x tan x. Do that one here. So I really want this video, I was going to continue with things that are where you need to use an identity. You won't need to use an identity here, but there's a skill you need for some of the later problems. So what I would do here is work on getting the negative sine x over to the other side. When I do that, I'd have sine x tan x minus sine x equaling 0. Right now, there's two different trig functions in there, and there's not an identity that I know that can easily get rid of the tangent x and give me only sine x. Tangent is both sine and cosine. So instead of doing that, what I'm going to do is factor and see if I can isolate sine and tangent in different factors. And so like if I factor out sine x, I'd have a tan x minus 1. See how that sine x would get distributed to here and produce this equation? But see how now the sine and the tangent, the two different trig functions, are isolated in different factors. So I can set each of those factors equal to 0, and I have these two equations that I need to solve. So now's when I think about my unit circle. I think about how I'm looking for the sine of some angle to be 0. So I normally look right here, and I think about sine as being the y coordinate. So on the unit circle, I'd have to be either right here, okay, to have a sine of 0, or I could be over here. So sine x equals 0 when x equals 0, or pi. And you don't say 2 pi because remember we're solving on the interval where x is between 0 and 2 pi, including the 0. Okay, so that's it for that side. Now, when I come over here and I look at tan x equaling 1, I know that tangent of something is the sine. So this would be the sine of x over the cosine of x. So the sine and the cosine would have to be the same for me to get a 1. So I know that this angle right here would have to be pi over 4. That's in the first quadrant. Okay. Or it could be in the third. So that's in the first quadrant. Or you could be over in the third one where you have a negative square root of 2 over 2 and another negative square root of 2 over 2. And that would happen, let's see, that would be 5 pi over 4. Okay. And so you get 4 answers. It doesn't really matter the order, I don't think, when you put them in there. But we get these 4 answers. Okay, for the solutions for what x would turn out to be. Now, the main reason I wanted to go ahead and slip that one in there is that idea of sometimes having to factor in order to separate and isolate your trig functions so that you only have one trig function in your equations. So that happens occasionally. All right, but now let's continue with the idea of using identities to help you. All right, before I do this one, let me put that other one I had. Let me just do it and put the easier one in there first. Then we'll jump to that one. So what if our next example involved cosine of 2x plus sine x equals 0? Okay. And so what I would do there is I would have my formula sheet and I'd be thinking about, okay, I don't want to have cosine, oops, drop my pen, cosine and sine. Okay, so I'm going to rewrite the cosine of 2x so it only has sines in it. Hang on, I got to go get my pen. Okay. Okay, so you can look at your formula sheet and see that there's lots of different ways that you could replace the cosine of 2x. But I'm going to pick the one that involves only sine. So I know cosine of 2x is 1 minus 2 sine squared x. And then I already had plus sine x equals 0. Now, one of the things, do you see the difference between a sine squared x and let's say if you had a sine 2x? Okay, those are very different. This is part of the argument. And sine squared x really means the same as a sine x, all getting squared. So sometimes just reading these can be a challenge. And then we're talking function notation here. So the 2x, sine of 2x, the 2x would be your input, okay, on something like that. So anyway, sometimes people really don't have good function notation skills, and then that kind of throws you a little bit when you're trying to think about these. All right, so now at this point, I'm looking at it and I'm thinking, well, let me put my squared term first, then have my sine x, then have my 1. I'm taking the sign in front of each of those terms, you notice. But I do not like to factor when this is negative. So I personally will come in here now and multiply by -1 on both sides. Because then I'll have positive 2 sine squared x minus sine x minus 1 equal to 0. All right, and then that sets me up to be able to factor. So a 2 sine x and a sine x gives me this part. I know I need a 1 and a 1. I'm going to make this one negative and that one positive so that here I get a 1 sine x and the outside 2 give me -2 sine x, which gives me the negative sine x that I need, and then a positive times a negative gives me a negative. Okay. All right, and then I'm going to set each factor to 0. And we'll wind up, oops, I didn't mean for that to change colors. Then we'll wind up just solving each of those equations, trying to get the sine x isolated. So subtract 1, divide by -2. Over here, I'm going to add 1. Okay, and then you go to your unit circle and you think about where you need to be. So for the sine to be 1, I got to be up here, right here, which makes x equal to pi over 2. And again, we're only solving from 0 to 2 pi now on this part of the sheet. Then you're going to go and look at your unit circle and look for where is the sine equal to -1/2, and it equals it right there and also over there. So you need to report both of those. And it needs to be between 0 and 2 pi, so you don't go in the negative to rotate. So you got to report this guy and that one. So this one is pi over 6, short of 2 pi. Okay, so this part right in here would be pi over 6. And so you're pi over 6 away from 2 pi, and 2 pi equals 12 pi over 6. So x could be 11 pi over 6. Okay. Or you could be over here, which is pi over 6 past pi. Okay, so this is like 2 pi minus pi over 6. This is like not 2 pi. This is like pi plus pi over 6. So that would be 6 pi over 6 right here, plus another one would be 7 pi over 6. Okay. So that's the answers you would get for that side. And then sine of pi over 2 would equal 1. So your three answers are 7 pi over 6, 11 pi over 6, and the pi over 2. Okay. All right. So in example 8, I looked at the one where you had to do a little bit of factoring there. Okay. In problem number 9, I went back to working through problems where identities were needed. Okay. This one, isn't that the same as the one I did over here? Yeah, this was the same as example 8. So let me change this problem to be another one that needs an identity. Let me see, which one was it? Oh yeah, wanted to do this. Make sure I don't have it written down for later. Yeah, I want to look at this one. What if you had sine x cosine x equals negative 1/2? If you had that problem, it's an issue because you have two different trig functions, but you can't separate them into factors that are equal to 0. See, we could do that on the other one. So what's going to happen is I'm going to need to try to get only a single trig function. So here's what I thought about. I thought about multiplying both sides by 2. If I do that, I get a 2 sine x cosine x. 2 times negative 1/2 would be negative 1. But the reason I did it is I recognized, or I saw that I could change that into 2 sine x cosine x, and I know that I can substitute sine of 2x in there. So sine of 2x has to equal a negative 1. Okay. So I can think about where on the unit circle would my sine be negative 1, and I'd be right there. So this 2x would have to equal 3 pi over 2, because that's the spot where the sine would be negative 1. Okay. Now, this is one of those with multiple angles. So this is one where you have to think about sine has a period of 2 pi, so add in that multiple of 2 pi there, and then divide by 2 everywhere. Everywhere. So this becomes x. This becomes 3 pi over 4, and here the 2's would cancel out, and you'd have n pi. So we're going to let n equal 0 and see what happens. Right? When we do, x turns out to be 3 pi over 4 plus 0 pi, which is 3 pi over 4. And we keep going with these n's until we get past 2 pi. So we'll do 3 pi over 4 plus 1 pi, which is 3 pi over 4 plus 4 pi over 4, which is 7 pi over 4. So there's 2 answers so far. You see, when you get to n equal 2, that's too big. So when you put in a 2, oh, wait a minute, I got to stay within 0 to 2 pi, so that would get me past that. So my answer would be the 3 pi over 4 and the 7 pi over 4. Okay. All right, and then let me go ahead and squeeze this problem in. You're going to need a calculator, so if you don't have one, go find your calculator. I got to go get mine because this one right here isn't going to be on the unit circle. So you want to try to picture where you're at, what this angle needs to be. Okay. All right, I'm going to go grab my calculator. Okay, so what I'm thinking about is I have the sine, and remember how we can think about that as some angle? The sine of some angle equaling a negative 0.2315. Okay, so I can kind of tell where I'd be. I'd be down here because sine is the y coordinate. And so for the sine to be negative, I'd have to either be down here, or here's another spot that would have the same exact sign. I worry about you making sense of this because reference angles, I didn't get a chance to, I didn't have many of you really there when I was talking through those. So I'm not confident that y'all really understand those like you need to. So I'm looking for the angle whose sine is a negative 0.2135. So I've got to depend on my calculator for this. So what I'm going to do is I'm going to do sine inverse. Okay. On both sides. So I'm going to come in and do sine inverse of the negative 0.2315 and see what it gives me. All right, now remember, you got to think about this now. When you're doing the sine inverse, you're going to be given an angle in here. That's the picture for both sine and tangent. So it's going to give you an angle in the first or the fourth quadrant. That's what the calculator is like programmed to do. So you have to understand that. So inverse sine of negative 0.2315 gives me back, oh, I got to check my mode also, by the way. So I want my mode to be in radians. So make sure you've checked that, put it in radians, and then do this, the inverse sine of negative 0.2315. And make sure that was entered correctly. I love a two line display so I can really double check what I plugged in. Okay, so yeah, I think that's accurate because it's really hard to think about. When I do sine inverse of negative 0.2315, I get another number, and what I get right here is a negative 0.2336. But that's like an angle. That's like an X in radians. And it's talking about the angle there, right there, being a negative rotation 0.2336, really in radians. Okay. All right. Now I could change that just so you can think about it for a moment. Could change that to degrees just so you could think about it for a second. So that's like a negative 42.05 degrees, just so you can reason it out. Okay. So your calculator only gives you that one thing back, but you need to get all the angles that would have a sine of negative 0.2315. Okay. So this is what makes this a little harder than some things. So see, this angle over here has the same reference angle right here. And see how that's going to be in 42-ish degrees past pi. Okay. So to get that angle, it's like pi radians, and then it's going to be that point, the positive 0.2336. So I'm also going to think about this being pi plus 0.2336 to get the other angle. Okay, and so when I do that, I'm going to be typing in my pi, it'll be a decimal, plus 0.2336, and I'm going to get the other angle being about, should have said about on this one, the other angle being about 3.375. It's just hard to think about that way because normally every time you're given an angle in radians, it's got a pi in it. Okay, but this really makes sense if you think about it, because isn't pi the number 3.14? And so see how you're just past that a little bit? You're past that by 2.336. So that's where this, no, I put the decimal in the wrong spot. I was wondering why that was so off. 0.2336. So that's where the 3.3736 would come from. Okay, and I typed it incorrectly in my calculator correctly, but the reason I'm getting something different than what you see here is because after the 3.14 is a 9, and so it all bumps up a little bit. So I just hit the pi button on my calculator, and I know this would be 0.2336 right here would be 0.2336 for the reference angle, and this amount of rotation is 0.2336. But here I'm going in the negative direction to get there. And here I'm going around in the positive direction. All right. So I've got to just kind of think about whether I've reported things in the way I'm supposed to. If they want the angle to be between 0 and 2 pi, okay, that means it's between, with decimals, it's between 0 and 6.14. Then this guy's good, but I need to change that. I can't leave it as a negative 0.2336. So I need a way to report that in a positive manner. So I'm going to do that in blue. Okay. So I'm going to go here all the way to there. So I'm actually 0.2336. So this guy right, not that one. This guy right here is really 2 pi minus 0.2336. And that turns out to be, I should have stopped while I was ahead. I'm getting tired. And this is going on longer than it should. Anyway, we can handle it. So that's going to be about 6.505. Okay, so the way you should report your answers is that X could be about 6.05. And if I needed 3 decimal places, it would be O. And then, or it could be 3.375. So that one was really the negative 2.2336, but I just converted it so that it was within 0 to 2 pi. Okay, so those would be your 2 answers there. All right. If you're like me, I think you might find the decimal part when they're decimals to be the most difficult. Okay. All right.